What does it really mean for an AI to think? Today, we're diving deep into distributed systems, strategic necessity, not architectural preference, global user bases, continuous availability, and planetary scale data demand systems that cannot exist on a single machine. Coordination across failure-prone components is now foundational infrastructure. This slide establishes why distributed systems are unavoidable. Scale, resilience, and data gravity have redefined the baseline for software. But here's where it gets interesting. The monolith ceiling. Vertical scaling hits physical and economic limits. Single points of failure guarantee downtime. Latency balloons with geographic distance. Deployment coupling throttles velocity. Moves from strategic importance to the concrete bottleneck that makes monolithic approaches untenable. So what's the real problem? Let's talk about the coordination tax. Distribution forces a trade-off: consistency versus availability under partition. Network asynchrony, partial failure, and clock drift make global state an illusion. Traditional ACD guarantees dissolve across process boundaries, identifies the root cause of difficulty. Coordination is the cost of decoupling, and the network is unreliable by design. This raises a critical question: consensus as primitive. Paxos, Raft, and Byzantine fault-tolerant protocols transform unreliable replicas into a trustworthy logical unit. Agreement on a single value becomes a building block, not an afterthought. Presents the algorithmic breakthrough that makes consistent distributed state possible without a central authority. Now let's zoom in on system model. A distributed system is a set of nodes communicating via asynchronous messages over an imperfect network. Assumptions are explicit: crash recovery, omission, or Byzantine failures. Synchrony bounds are specified, not hoped for. Frames the formal operating model that all design decisions will reference, makes the next slide's components necessary. Here's something most people overlook: core components, replication protocols, based, leaderless, partitioning strategies, hash, failure detectors and membership services, distributed transactions with atomic commitment. Breaks the system model into its essential mechanisms, each addressing a piece of the coordination tax. Think about this for a second. Request lifecycle. Client query hits a load balance gateway. Coordinator assigns a timestamp, logical or hybrid clock. Quorum-based replication ensures durability. Read, repair, and anti-entropy background processes converge state. Shows a concrete workflow that demonstrates how components interact to deliver a consistent result under failure. And this is where things get complex. Cap reality. Choose consistency and partition tolerance, latency suffers. Choose availability and partition tolerance, stale reads possible. Real-world systems tune per operation, not globally. Translates theory into an operational decision framework, reinforcing that trade-offs are designed, not avoided. But here's where it gets interesting: resilience impact. Self-healing through automatic failover. Horizontal scaling absorbs load without redesign. Geographic distribution brings data close to users. Downtime becomes a design flaw, not a calendar event. Quantifies the impact. Resilience, scale, and performance become system properties, not aspirations. So what's the real problem? Let's talk about observability surface. Distributed tracing, metrics, and structured logging replace single-host debugging. Telemetry pipelines must match the complexity of the system they monitor. Surfaces the new operational requirement. Observability is a first-class architectural concern, not a bolt-in. This raises a critical question: future substrate. Serverless run anywhere execution units. Edge native state with CRDTs and causal consistency. Data-aware routing reduces cross-region chattiness. Autonomous operation through control loops extends current architecture into emerging patterns, showing the trajectory toward fully adaptive infrastructure. Now, let's zoom in on new default. Distributed systems are no longer a specialization. They are the environment in which all significant software executes. The only remaining question is how well you leverage the primitives. Closes the argument from necessity to inevitability, positioning distributed fluency as the core competency.